going to be, from here on out, relatively new stuff that we will be talking about for the rest of the semester. There will be stuff that, or concepts that we have dealt with from last semester that will be embedded in the second semester, but there will be new things. So
It's going to be harder.
I think between you guys and my Math 95 111 kids, I feel like you guys will get this much quicker than they did. So I'm giving you a high pedestal. One of the key words or vocabulary that we're going to talk about today is a rational expression. Okay? And this right here, rational, this key word that you're going to see this entire chapter, really stands for fraction. So even above this or to the side, when I say the word rational, think of the word fraction. And even within my definition, is there a word that kind of hints at the word fraction? Quotient.
Yeah.
Quotient in math means dividing, so fraction. Okay, so a rational expression is the quotient of two polynomials. And last semester, didn't we talk about polynomials a lot?
Yeah.
Yeah. All right. What we have that I'm going to show you next is a couple of examples of some rationals. So let me scroll this sucker down. So those are three different types of examples of rational expressions. Okay. So they're separated. Here's one rational expression. Here's another one. You know, like when in English,
I thought it was
sorry.
like passed on. I was like, what the heck?
No, that's just separating to say that there are
Do we
three
need to
different
write
examples.
examples?
I would say for you to recognize them, that's a great place to have. Or if you want, why don't you create your own in your notes? I mean, take a guess and see how you could create your own rational expression. So Billy, you just created one. You said x over 5.
Yeah.
That is a perfect rational expression. Does anyone think they could come up with another one right on their own keister? What did you say, Janae? No, it's not. It's okay. They're wrong. Anyone try a guess? Try something else.
5 over x minus 4.
Okay, that works. Okay. That counts. I mean, that's smart. What if I said something like this? X squared minus 4x plus 3 all divided by x plus 4. Does that work?
That was way too much.
Yeah. Yeah, I just did the polynomial and divided by a polynomial. All right, and then one more thing I want to refrain. What is the degree if that was just the polynomial down there?
2.
2, and what does the degree stand for?
The highest.
Okay, good. All right, one important thing about rational expressions that I do want you to take note of is, let's scroll that down just a smidge, is the rational expression is undefined at any value that produces a denominator of 0. With fractions, think of like when we did our slope, when we dealt with linear equations. Anytime you have a fraction, 0 cannot be in the denominator. What happens when 0 is in the denominator? What is that called?
Undefined.
It's undefined. So if I were to ask you guys, basically looking at my 3 examples of my rationals, let's use the middle one for example. What would make my denominator 0 if I plug something in for this x? 2. So I would have to say specifically for this rational expression that that would be undefined when x equals 2. I never want to have 0 in my denominator, so you want to explain where it would happen in certain situations.
What is 0 on top?
0, well, if 0 divided by anything is any what? Is what?
0.
Is 0. The only thing I care about is if 0 is on the bottom. So like right here, Bree, if I had 0 on the top right here, what's 0 divided by 7?
0.
Does that matter? No. Okay. Are we all good? Does anyone need more time copying down my first little slide? No? Okay. All right, so one of the things that we're going to do, that we're going to talk about is finding numbers in my rational that are undefined. Okay, and what I'm going to do is I'm going to do this one with you, and then I'm going to have you guys try the next one. Okay, so we're going to find all numbers for this rational expression that makes it undefined. And what does undefined mean? Zeros in the denominator. Okay, so I'm going to test even your elementary skills today. Even before you had me as your teacher. You're a long time ago. I couldn't imagine being an elementary school teacher. Alright, so Janae, Wilder, Rose. Out of my rational expression, which one is the denominator? Hello?
X squared plus 2x.
There you go. So, when we test to see if things are undefined, you take your denominator, and we're going to set it equal to 0. We're going to actually solve my polynomial. Okay, and this is where we did some stuff at the very end of last semester that you guys presented on, and I think explicitly my gentleman right here. Okay, so how can I solve this? What do I need to do first?
Yeah, Kobe, what do we
I think it starts with a G.
Greatest common factor.
Greatest common factor. Okay, so let's do some, what's the greatest common factor that I can have? Okay, good. I mean, it's still new this semester. So if I factor out an x, what do I have left
X
in?
plus 2.
Okay, good.
And 7 is equal to 0.
Alright, so Will, Kobe, and Karen, remember this now, huh? Yeah. Alright, so is this now completely factored?
No.
No.
Both of them? Can I factor? Can I tell this one?
Yeah, I said yes.
So what do I do to now solve them?
You set both of them to 0.
Set both of them equal to 0. So I'm going to take x equals 0, as well as x plus 2 equal to 0. Okay, out of those two equations, which one is easy?
The left one.
The first one?
The first one. So what is one of my answers?
0.
Okay. And what about my second one? What is the
Negative 2.
Okay, so this is really telling me what x cannot equal. Right? Because what happens if I plug either in 0 in for x down here, or negative 2? What do I
Yeah,
get?
make the denominator 0.
Yeah, so when I ask for all numbers that are undefined, you can say, we'll say x cannot equal 0 and negative 2. Okay, x cannot equal 0 or negative 2. If they do equal those numbers, my rational expression becomes undefined, and that's a big no-no. Can I plug in 3 in for my x's? Am I okay? Yeah. Why?
Because it won't equal 0.
Because it won't equal 0. Alright? I want you guys to try this one. And if you have someone next to you, you can discuss it. There we go, perfect. If you need help, talk with the person next to you, but I think that I did a little bit of an easier one to guide you. Just because I know we had a little bit of a frustration with our factoring. Yes, ma'am. So, think back our first example. I set my denominator equal to what? So,
I don't know if I can calculate.
so then how would you solve
What?
that? How do you solve 2x minus 5?
Decimal is like the fraction or
So what was your number?
2.5.
Okay.
Okay. I got 2 per but I left in a fraction, so I got 5 over.
Yeah.
Okay, let's see.
You want it in the fraction or do you want it in the decimal?
For this one, I don't think I care.
Okay.
I mean, usually I prefer it as a improper fraction, but even a decimal would be fine.
What if I'm a GCF?
Is there anything you can take in it?
No.
So then how would you solve that? How would you get x by itself?
Is that all you do?
What?
X is.
2x minus 5.
X cannot
Oh,
equal
you would
5.
add binary.
Yeah, because there's not a second x, because there's no greatest common factor.
2x equals 5.
Perfect. Alright, so can I have someone who didn't do the warm-up go up here and solve or tell me what is my value that x is undefined? Someone new.
Oh.
just did it for me. Show me what value for x can be undefined. Okay, I'm gonna sit in your spot. So, bro.
So, I took this right here. 2x minus 5, I set it equal to 0. And all you really have to do is just take this 5, add it to both sides, and you'll get 2x equals 5. You need to divide it by 2.
So you're there. Okay, so why on this example did I not have to factor?
Because there wasn't any,
There was no
raising factor.
Okay, so let's go back and kind of see, what was the degree of my polynomial denominator? It was 2. Remember as a guideline, if you have a degree of 2, most likely you're going to have to factor. What's the degree of that polynomial that we have? Okay, that's a linear equation. Solve it just straight through. Okay? So that's very, very good. Are we understanding what to check for rational expressions that are undefined? Yeah. Okay. The only other thing that we're going to talk about today is simplifying rational expressions. Okay? And there are only 2 steps in knowing how to simplify rational. So let's get this. We got the herd of the junior high coming. Okay. Let's see how well Mrs. Granberg or Poppin taught you. Can anyone give me a synonym for the word simplify?
Reduce.
Reduce, okay.
Wait, does it have to be one word?
I mean, multiple. Maybe some.
Smaller?
Make smaller, okay. That's a phrase, I like that. I would say make skinny, you know. Simplify. Initially, when I talk about this, rational expressions are fat, a little bit overweight. But when we simplify them, we're going to do some P90X, some insanity, all right, and then we're going to make them skinny.
So we're going to make them work out.
We're going to make them work out. Okay? What you're going to do, it's in 2 easy steps. And this is where last semester at the end, when you guys did your presentations on factoring, that it's really important because it's going to come back. This whole chapter is if you had hard times factoring, we're going to have to review it, and you're going to have to come see me. The first thing that you're going to do is look at both the numerator and the denominator of your rational, and you're going to factor both of them. See what you can do. So all of the methods of factoring, can someone, besides saying greatest common factor, another way that we factor polynomials?
Method.
So what's that called?
Factor.
It is factoring, but it's...
No, I just call it X method.
Addition.
Okay, addition, multiplication, which means product and sum.
Yeah.
So product and sum method, what's another one?
Bottom
Bottoms up. What's that one where there's 4 terms in a polynomial? Grouping.
Those have been saying that for like 10 minutes.
Dots.
Dots, difference of 2 squares. Okay, any one more?
What does it start with?
So,
Oh, good job.
so, good. Alright, so step 1, Cam, you're going to factor out denominator and numerator. And then the second step is you're allowed to cross out or cancel or anything if you get the same factor on both the numerator and the denominator. So if you get the same thing, you can cross it out, and that's how we're going to make it skinny and simplify it. Okay? So we're going to actually try a couple of these before I throw you to the wolves. Okay? The wolves. Alright, so let's try this one. Yeah, let me get this a little bit. Did you still need the top part? Can I at least, should I keep the second part? I like to move my smartboard, I'm sorry. I wish I could take it home with me. Today, honey, we're going to make some chicken marsala. I would love to have a smartboard. Oh my gosh. No,
He's gonna go buy a